Hello everyone. So today we are back again with another new topic, that is fluvial landform. Before starting with the topic, I'd like to request every one of you to please subscribe our channel. Those who are new to it, for this you just need to click the bell icon, and if you like the video then please click the like button and share it up. Now going straight towards the topic, we need to understand what does the word fluvial means to us. Sometimes we used to relate the word fluvial with water. So here also the work of the running water is in the form of the surface runoff or overland flow, and the stream is most important to all the exogeneity or the plantation processes, and the running water is mostly widespread in the exogenetic processes in this earth. The exogenetic processes consist of the two action, that is, one is erosional activity, another is a depositional activity. This depositional and erosional activity altogether form the fluvial processes, which include the overland flow, that is the surface runoff, and the stream flow. Now we need to identify the erosional activities is mainly the carried out activity, and the built up activity is deposition. Firstly, we are going to discuss about erosional activities in details. Before discussing the erosional activity, we need to note what does the erosion means to us. The erosion is being derived from the Latin word which means erodere. Erodere means to grow. So erosion is a dynamic process which involves the removal of the geomaterials of the rock and other deposited materials. According to a famous geographer Thornberry, he also remarked this erosional work as it is a true of course that the weathering is a preparatory stage and may have erosion, but it is not prerequisite to, not necessarily followed by erosion. Next, we are going to identify the various processes through which the erosional activities takes place. There are altogether 6 processes which we are going to deal up, that from which the erosional activities take place. The first one is the solution or the corrosion. This is a solvent action of the water as it flows over the carbonate rock, and this we have to keep in mind. The solution always depends upon the purity of the water and solubility of the water, while the cavitation is mainly caused by the constriction of the flow, and it rises of the velocity, and the kinetic energy is formed in the stream. This is being compensated by a decrease in the pressure of the water that leads to the formation of these air bubbles. And on the other side, when the stream channels widens up, this widening of the stream channel always decreases the velocity and the pressure is increased, leading to the collapse and imposition of the air bubbles. This sent the miniature shock waves, and this shock waves gives a much important and a strong effect on the nearby rock, which particularly is affected on the rock steps in the rapid and the waterfall. The continual repetition of cavitation process gives or finally breaks down the rocks. While the important action is a hydraulic action, which is a very common in this fluvial processes. This is being mainly performed by lifting and carrying effect of the rushing water, and the force of the moving water, it dislodges the rock. When the impaction, the effect is of blown up of the river bed and banks by the large boulders that are being bounced during the floods. So this impact or the impaction activity is mainly impacted more in the flood prone areas. The abrasion and corrosion, though common, but it is activity when the stream uses the load to scrape up its way from the bed, and particularly in stream confined to the sections of the stream channel. In the cases of attrition, it involves the shattering and breaking up of the stream load through collision and mutual abrasion. Altogether, this leads to the rounding of pebbles and boulders and decreasing of the size. These pebbles and the boulders, which we usually observe towards the side of the rivers which flows in the mountainous areas, are examples of the attrition. Next, there are various type of landforms which we are going to discuss in details. Firstly, we are going to discuss about the erosional landforms one by one. The first one is the V-shaped valley. As the name suggests, V-shaped valley, basically because a V shape or the shape is formed in V manner, like here. Now, how this has been formed? Basically, this has been formed by the rapid cutting and deepening of the stream flow, which remains comparatively narrower than the valley side, and this gives rise to a V shape. So here in this diagram, if we see, there are two valleys and a stream is flowing in these areas, and this gives to a steepening of the floor, giving rise to a V-shaped valley. Also, this gives a very picturesque diagram. In this we have seen it's a very picturesque. Next, we are being finding out the various forms of V-shaped valleys are formed. The V-shaped valleys are formed in basically three forms, that is a gorge, canyon, and structural benches. The first is a gorge, which has a steep precipitous wall with which a narrow river is confined, and this results in the channel deepening and the recession of the falls. In this diagram, if we notice, there is a steep precipitous wall on both the sides, and the narrow river is being flowing, which is mainly confined, and it results in the channel deepening. The examples are of Rhine gorge in Europe and Zambezi gorge in Africa. This is an example of the Zambezi gorge, which is mainly found in Africa. Next, we are going to find out about the canyons, which is a steep slope and narrow river bed, and it is predominant due to the vertical erosion. The narrowness of the valley is determined by the vertical erosion and also on the humidity over the area. Grand Colorado is an example of this canyon. This is a picture of the Grand Canyon of Colorado region. Now in this picture we are going to find out how the steep walls have been formed on both the sides, and the narrow river on the beds which are being seen always flows in this area, and the predominant erosion is mainly taking place. Here we need to note out that the vertical erosion plays a very important role in these areas. Moreover, the humidity over the areas is very important, which also leads to the canyon-like structure. Then next we are going to identify the structural benches. These are sometimes formed by the harder and softer rock may lie down alternatively in V-shaped in a horizontal manner. So here in the canyons we have seen that it has been formed in a horizontal manner, while in a canyon it has been formed in a vertical erosion, while in a structural benches it has been formed due to its horizontal manner. Here it has been horizontal manner, it has been formed. So here in this diagram, if we see that this has been formed in a horizontal manner, V-shaped, and in this diagram it is clearly evident there is one harder rock and there is one softer rock. The harder rock erodes lesser compared to the softer rock and gives rise to a structural benches. The erosion leads give rise to a steep-like valleys. The next we have rapid, and the part of the rivers where the current is flowing with more than that of the normal swiftness. The rapid may be caused by a sudden deepening of the slope and by unequal resistance of the successive rocks that have been traversed by the river. This is more often due to the outcrop, which is usually seen of hard crops, and the erosional activities are less because of the resistant rock. There are various diagrams showing various cases when these rapids have been formed. For example, in this if we see that these are the outcrop areas where it is very hard and resistant, so rapids are being formed. In the first diagram on the right side, if we notice, we have seen that these are the low resistant rock while these are the hard resistant rock, and when the water is flowing there is a sudden opening of these areas. This gives rise to a rapid, and in another case the hard resistant rock is there and these are the soft, and as the harder rocks erode lesser compared to the softer rock, or softer rock erodes more, so this gives to a deepening of the channel, and the turbulent water flow over these areas gives rise to the formation of rapid. This is not the end of the erosional activities. The later erosional activities we are going to discuss in our next video. So please subscribe to our channel so that we can give you information about the next video. Thank you.